Hello, this is Rohan-Paul. Very welcome to my machine learning and deep learning YouTube channel. Let's get started. So in the last video, I did a simplified implementation of grid search CV function without using scikit-learn and with pure Python. And in this video, I'm going to do the same with random search CV. So this video, I am going to implement random search CV without using scikit-learn with pure Python. And again, just like the previous video, this function is going to accommodate only k nearest neighbor algorithm, because if I want to accommodate other algorithm like XGBoost, LightGBM, random forest, etc., this is going to become much larger project, and that is almost going to be equivalent of scikit-learn. And again, the purpose of these from scratch implementation is to learn the under the hood mechanism of how grid search CV or random search CV works, and in general how k-fold cross validation is implemented in our training. First, a quick recap on hyperparameter tuning methods and the differences between hyperparameters and parameters. So hyperparameter tuning refers to the shaping of the model architecture from the available space. In simple words, it is about searching for the right hyperparameter to find high precision and accuracy. And the most widely used parameter optimizer techniques in classic machine learning are grid search and random search. Now, the difference between hyperparameters and parameters. So parameters are the variables that are used by the machine learning algorithm for predicting the result based on the input historic data. These are estimated by using an optimization algorithm, for example, gradient descent. Thus, these variables are not set or hard-coded by the data scientist. These variables are produced by model training. Examples of parameters are coefficient of independent variables in linear regression and logistic regression, or the weights in neural network training. And now hyperparameters are the variables that the data scientists specify usually while building the machine learning model. Thus, hyperparameters are specified before specifying the parameters, or we can say that hyperparameters are used to evaluate optimal parameters of the model. And examples of hyperparameters are a max depth in random forest algorithms, or the k in a k nearest neighbor classifier. So hyperparameters are not the model parameters. That's the main point. And it is also not possible to find the best set of model parameters from just the training data, because model parameters are learned during training when we optimize a loss function using something like a gradient descent. So in the grid search or randomized search tuning technique, we simply build a model for every combination of various hyperparameters and evaluate each model. The model which gives the highest accuracy wins. The pattern followed here is similar to the grid, where all the values are placed in the form of matrix. Each set of parameters is taken into consideration and the accuracy is noted. Once all combinations are evaluated, the model with the set of parameters which gives a top accuracy is considered to be the best. So now look at the grid search CV architecture. So in grid search, it uses different combination of all the specified hyperparameters and their values, and calculates the performance for each combination and selects the best value for the hyperparameters. This makes the process time consuming and expensive based on the number of hyperparameters involved, because you are not leaving any single hyperparameter, you are not leaving any values of a single hyperparameter. That's why it is called an exhaustive search, that you are looping through each and every possibilities, each and every combination. Now compared to these, so that's the limitation of grid search CV, that grid search does not scale well. There is a huge number of combinations, so we end up testing for just a few parameters. For example, if we have 4 parameters and we want to test 10 values for each parameter, then there are 10 into 10 into 10 into 10, that is 10,000 combinations possible. And all right, so now let's look at the randomized search CV. So here in random search, it's a technique where random combination of the hyperparameters are used to find the best solution for the built model. So the randomized search follows the same goal, However, we will not test sequentially all combinations. Instead, we try random combinations among the range of values specified for the hyperparameter. So here, initially, we specify the number of random configurations we want to test in the hyperparameter space. And the main advantage is that we can try a broader range of values or hyperparameters within same computation time or as compared to grid search, or test the same ones in much less time versus grid search. But the problem is that we are not guaranteed to identify the best combination, since not all combinations will be tested. This works best under the assumption that not all hyperparameters are equally important, and which is indeed true for many classic machine learning algorithms. Both grid search CV and randomized search CV implements k-fold cross-validation. So let's quickly recap what that is, as in this slide. So k-fold cross-validation is the most popular type of cross-validation. It is an iterative process that divides the trained data into k partition. That is, let's say the iteration number 1, the whole data set is divided into one k different partition, and each iteration keeps one partition for testing. Like in this case, this is the testing part, and the remaining k-1 partition for training the model. So the next iteration will set the next partition as test data, and the remaining k-1 as trained data, and so on and so forth. So in each iteration, it will record the performance of the model, that is, calculate the accuracy or the precision, and at the end give the average of all the performance for that iteration. So this is the whole k-fold cross-validation in a nutshell. And now the actual code for implementation of random search CV. This is my notebook. Definitely, I'm going to share the GitHub link of this in the description section of the video. So the first is just importing some standard library. The make classification module of scikit-learn is just to create some dummy data, classification data for on which this random search CV function I'm going to test. Then a normal train test plate to split my data set, and the numpy, the random module of Python, because I'm going to we have to generate random variables for implementation of random search CV. And this tqdum package is just to show a progress bar kind of thing when a long loop goes on. So the first step is just to creating some dummy dataset with make classification, and I discussed it previously, these parameter meaning, but just quickly go through it again. So if you go to the official documentation of make classification, this generates a random in-class classification problem, and number of samples is just the number of samples, that is the number of rows. The number of features in features is the total number of features. These comprise in informative information features, in redundant features, and in repeated duplicated features. So in informative is the most important part, that the number of informative features. It is as simple as this. And in redundant, by default it takes 2. That is it's the number of redundant features. These features are generated as random linear combinations of the informative features. So you may choose to have no redundant features in your dataset. That is a choice I have made for this exercise. So I am giving the number of samples. I'm generating a 10,000 samples. Number of features 2. In informative features is also 2. And I'm setting the in redundant equal to 0. That means I will have no redundant features. And number of clusters per class is 1. Random state 60. By specifying the random state, I am making this whole generation of this data set is more reproducible. That is, it will create same sequence of random data set each time it is run. Because when you want to test your code and you want to test the output of a function on these features and on this generated data set, you want to give a random state a particular integer, because you want your output to be reproducible so that it can be compared with one output with another output. And then the regular very famous train test split. I'm just splitting my original generated X and Y to train set and test set. All right, and if you just print the shape of this my train set, it will create 75% as train, and that's my 7,500 of training data set out of total 10,000 samples. And then just to check that how this data set actually plots, I'm just creating a very simple scatter plot, and this is my data set that I created above in the above cell. So this is how the this is going to be a classification kind of problem, because I'm implementing KNN here. That is, I want to apply KNN algorithm on to find the best K to get to apply to see how my random search CV custom function is working. And that's why this is a classification data set that I have created, and you can clearly see the demarcation of the how the data set is scattered in the space. All right. And this is a little pseudocode for the custom random search CV. And to repeat again, the whole purpose of doing the random search CV is to get the optimal K of KNN algorithm, which will produce the best accuracy for my training dataset. So that's the whole purpose here, to get the K value for which I will get the best accuracy. And this is the actual code here. And I have put actually detailed comments for anybody looking at the code to understand the flow in detail. So definitely I'm going to share these link in the description of this video. So fundamentally, to understand the flow for random search CV, that it will randomly select some values from the hyperparameter, and K is a hyperparameter here, and then with that value of the hyperparameter, it will run each fold, and all the accuracy calculation for each fold will go in the inner loop. So there will be two loops. Outer loop will move through the values of the hyperparameter, which is n neighbors in the case of KNN, and then the inner loop will loop through the calculation under each fold. So let's quickly check. And the main difference between grid search CV and random search CV is grid search CV will move through or loops through each combination of hyperparameter values and under each fold, but the random search CV will randomly select some hyperparameter values to do its calculation. That's the main difference. And this line is that line of the key defining factor of random search CV, that it's randomly selecting some values from the hyperparameter params range. So this param range in this random search CV custom function, param range is an argument to the function, and this line will just randomly sample or randomly select 10 values from this param range. So like I have put in the comment, generate 10 unique values from uniform random distribution in the given range, starting 1 to param range. For example, if param range is equal to 50, we need to generate 10 random numbers in range 1 to 50. And okay, then these classifier params here, I have hard coded it to be n neighbors, because like I said again, this function is a very simplified version, so it will only accommodate KNN algorithm, and in KNN, n neighbors is the hyperparameter, and this is set equal to these randomly generated 10 hyperparameter values from the param range. And with these defined, now we will move through two loops that I was just talking about. There will be an outer loop and there will be an inner loop. The outer loop moves through these values of n neighbors, and the inner loop moves through each fold value. So number of fold, this variable is input to the function, or an argument to the function, number of total fold, and then the inner loop do all the calculation under each fold of this number of total fold. So again, the outer loop, I have already in this loop, these data of moving through the various values of n numbers will start, and then The most important loop is, of course, the inner loop where the whole fold calculation is going on. And so let's check out the calculation for a single loop. So the first is number of elements in each fold, and that's a very simple, that the total length of the X trained data set divided by the number of total folds. So if I have 100 sample and I have number of folds equal to 10, then I will have the number of elements in each fold is also equal to 100 by 10 equal to 10. And then I have to implement the most important concept of fold here. That is, I have after dividing the whole data set into k fold, I have to separate the test set, which is one single fold out of 10, and the rest 9 will be my training set. So this is what I'm doing here. The test indices, this variable will hold only the indices of the test set. That is a single set out of all the k different set of the data. So test indices is simply a group of data from starting at the start of one group and ending at the start of the next group. And that's what you can say here, the number of elements in each fold multiplied by the fold number. This is the starting point, and the ending point is the number of elements in each fold multiplied by fold plus 1. Because fold will be a successive number, 0, 1, 1, 2, 3, 4, 5, 6, like this, not 0. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Say I'm doing a 10-fold cross-validation here. So my each fold, under the fold, the test indices will be a single fold, and these range will extract that single fold by extracting data from starting of one fold to the starting of the next fold. And then the rest, after I select the test indices, that is a single fold, the rest all the folds, all the data will be my training set. And this training indices is doing just that. From my whole X train total, it is just deducting these test indices that has already been decided here. So the whole rest of the data set is my training set. So yeah, I have put in really detailed comments here. You can, if you look into the code in GitHub, you can definitely make sense of it. And let's move on. So it is just another, again, explanation of this fold concept. So for a data set of total 100 rows, one loop of fold will have the following test indices and train indices kind of split. So in this case, I'm just assuming I have 100 rows of data or 100 sample, and my test indices, let's say I'm doing a 3-fold cross validation. So one fold of data will be my test indices. Let's say these are all those 0, 1, 2, 3, 4, 5, 6, 7 up to 24. Then all the rest of the indices will be my train indices. All right. So yeah, it's a very obvious if you read through it. And then given now, the whole flow of the code is just like what we did in the last video in Grid Search CV. That is, the structure of the code is exactly the same. So now that I have my test indices and train indices decided, I only have to extract the data from using that indices. And these 4 lines is doing just that. Pretty simply, it's doing my actual data set of X train, Y train, X test, Y test by using these indices number that has been already captured here, above here. All right, so my data is fully ready. Now all I have to do is run knn and predict it and get the accuracy. And after I get a single accuracy, I have to do for all the folds and then get the mean. And that's all these 2 blocks of code is doing. So here I am still inside the inner loop where I am defining the classifier.neighbors to be k. Remember, this neighbor is the actual parameter name in scikit-learn's k neighbor classifier. This module of k neighbor classifier has an exact parameter called neighbors, which represent the k values. And that's what I'm doing here. I'm just defining classifier.neighbors equal to my k, and the k, remember, it's a value of these current loop that I'm running. So in neighbors will have different values, and k will represent those values like 3, 4, 5, 10, or whatever. All right, now I'm just with that k, my k is defined. Now I'm just fitting the data on x train fold and y train fold, that is this and this. And after fitting, then my model is fully trained. Then I'm ready to predict. And now my y predicted, first I'm doing on x test fold. That's my y predicted. This is actually, I can rename it y predicted test. But yeah, let it be. I'm not editing the code right now within the video. So yeah, so first I'm doing the y predicted for x test fold, and then I'm doing test score folds dot append accuracy score, because I have my y predicted value ready now, and my actual ground truth of y is here anyway. So now I'm ready to calculate the accuracy score, which I'm doing here, accuracy score y test fold and y predicted, and that accuracy I'm appending to this variable. I'm doing exactly the same for the trained data set. And then finally here I'm out of the inner loop. So here with the final array, this train score, this is the final array, and that will calculate the mean values of each of these accuracies. So I'm just making use of this numpy mean value, np.mean, and I am appending to these final two variables the mean of train score folds and test score folds. And this two variable is the final output or final return values from this function. Yeah, so now this function is done fully. This function here, it looks visually it looks large, but it's actually very easy. It visually looks large because I have put in so much of comments here, but it's actually just, I think, maximum 15 to 20 lines of code. And now that my function is done, I am ready to test it to see how what kind of output it generates, and what kind of plot it generates, because I also want to see the ultimate motivation of doing all these, that is what is my best k, what is the best value of the hyperparameter k. So in this cell I'm just importing k nearest neighbor from scikit-learn, and then I am defining a variable with the k nearest neighbor class and setting my params range to be 50, number of folds equal to 3. And then I'm running my whole this function that I just defined above, that is randomized search CV custom, and passing x train, y train, neighbor is this neighbor, which is k neighbor classifier of scikit-learn. Param range has been defined to be 50, number of total folds is 3. And if I print the output, I will get this kind of arrays. Remember, these array are the mean values of the accuracy. So this is the mean value of the accuracy score from train score, and the second array is the test scores. And now this is the final step, which is I just want to see if they are making sense at all by looking at the plot. So in this plot, I'm only plotting the k values, that is hyperparameter k values, and the accuracy. And so we have to choose the k to be the most optimal, where my test accuracy is maximum, and also the distance between the test curve and the train curve is at the minimum. So looks like, looking at the plot, my test accuracy probably touching a max something probably here at the value of 42 or 43 somewhere, as far as I can see from bare eyes. And also the distance is kind of the smallest between the train curve and test curve at this point. So for this dummy data set, if I want to apply k and n on this data set, the best optimal k that I'm going to use is 42 or 43. That's the whole purpose of the entire random search CV. So yeah, that pretty much wraps up this video. And if you like the video, don't forget to hit the like button. And also, I plan to upload videos quite frequently to my channel, so please consider subscribing. All right, see you next time.